Welcome to OOTO TV, the out-of-the-office investigation, from the past into the future of artificial intelligence. This time we're discussing agentic design principles. I'm your host, Bob. Today we're jumping into the very blueprint for creating the kind of intelligent systems that are leaping right out of science fiction and into our daily lives. And look, we're not talking about simple apps or tools anymore. We're talking about building autonomous agents. These are systems that can actually perceive their environment, reason about what's going on, and then take action on our behalf. It's a massive, massive leap forward.
I'm Sue, and it's great to be with you for this. Bob, you're so right. This is a huge topic. So for our investigation today, we've laid out a 6-part journey. We're going to start with the absolute fundamentals, the 4 core jobs that pretty much all AI is built on. From there, we'll look at how developers actually assemble those building blocks into what we call an intelligent agent. Then, of course, we'll get into the real-world stuff, how these agents are being used in business to create some serious value. But that's where our focus is really going to deepen. We'll pivot to the absolutely crucial questions of human control and oversight, and then we have to confront the inherent risks, things like bias and the erosion of autonomy. And finally, we'll wrap up by exploring what it's going to take to design a responsible future for these unbelievably powerful systems. I really see it as a path from pure capability to profound consequence.
I'm Bob. And you know, to really get a handle on agentic design, we have to start with what AI does at its very core. It can seem impossibly complicated from the outside, but thanks to the brilliant work of designer Chris Noesel, we can actually break it all down into just 4 fundamental jobs. Think of these as, like, the primary colors of intelligence. By themselves, they're pretty simple, but when you start mixing them together, you can create basically any AI masterpiece you can possibly imagine.
I'm Sue. That's a perfect analogy, Bob. So let's start with the first one, clusterers. Their whole job is to look at a massive, messy pile of data and find the hidden patterns, organizing things into logical groups. You know, imagine your favorite streaming service looking at millions of users' viewing habits and clustering you with people who have similar tastes, all so it can recommend a new show you'll probably love. That's a clusterer at work.
I'm Bob.
Exactly. Okay, next up are the classifiers. These are the real workhorses of AI. Their job is to look at a single item and tell you what it is. I mean, if you've ever used an app like Shazam to identify a song that's playing, or if your email automatically sorts a message into the spam folder, you've just used a classifier. It's all about putting one thing into a known category.
I'm Sue.
Right. And third, we have regressors. These are kind of like the fortune tellers of the AI world. They analyze all the relationships in data to predict a specific number in a range. So when your GPS estimates your arrival time will be 4:32 p.m., that's a regressor in the background, calculating your speed, current traffic, and distance. It's also the exact same tech a real estate website uses to spit out an estimate of a home's value.
I'm Bob.
And finally, we get to the fourth, and you could argue the most powerful job, generators and optimizers. Now, this is where things get truly mind-bendingly creative. These AIs don't just analyze the world as it is, they create entirely new things within it. We're seeing this everywhere now. AI generating images, writing code, or even composing music. They are fundamentally changing what creativity even means.
I'm Sue, and you know, it's worth spending just an extra second on classifiers, because the detail here is so important to how these systems actually work. They don't just give you a simple yes or no answer. They give you what's called a confidence score. So let's say you show a classifier an image of your pet cat. It won't just come back and say cat. It might give you a whole list of probabilities, something like 99% confidence it's a mammal, 90% confidence it's a domesticated cat, maybe 89% confidence it's orange, and here's the interesting part, maybe even a 31% confidence it's a lion.
I'm Bob, and that little bit of nuance is absolutely critical, Sue. It really is. That's how the system expresses uncertainty. That low confidence score for lion is a signal. Now, in a low-stakes system, like your photo album, it just ignores it. Who cares? But in a high-stakes system, say medical diagnostics, that uncertainty is the trigger that basically flashes a big red light and says, a human expert needs to look at this right now. It's the very basis for how humans and machines can collaborate effectively.
I'm Sue, and that's really the crucial point here. On their own, these 4 jobs are just incredibly powerful, very specialized tools. A clusterer organizes, a classifier identifies, a regressor predicts, and a generator creates. But the real magic, and as we're about to see, the potential danger, all of it emerges from how we decide to weave them together. Agentic design is the art and science of combining these simple blocks to create systems that can pursue really complex, multi-step goals. And that's where the implications just become truly profound.
I'm Bob. So that's the big question, right? How do we make that leap from these individual building blocks to something we can honestly call a true agent? Because an agent is so much more than a tool.
It's a system that's designed to perceive its environment, to reason about what it perceives, and then, most importantly, to take action to achieve a specific goal. It's all about stringing these jobs together in a sequence, creating a loop: observe, orient, decide, and act. A simple tool responds to your command. An agent actively pursues an objective.
I'm Sue, and this brings us to a really critical question, Bob. We see the incredible potential of these building blocks. It's amazing. But for the people listening to the OTO TV investigation who are trying to solve real-world problems, let's get down to it. How can agentic design be a successful method for business solutions? I mean, this is a multi-trillion-dollar question about turning raw technical capability into tangible, real-world value.
I'm Bob, and the answer is just incredibly exciting, Sue. The bottom line is this: agentic design is a modality to achieve business continuity while achieving rapid growth. Okay, I know that might sound like a bit of business jargon, so let's break that down. Business continuity just means stability, keeping the lights on, keeping things running smoothly. Rapid growth is the complete opposite. It's about expansion, change, moving fast. The magic of agentic systems is that they let you do both of those things at the same time. We're building systems that are active participants in the business. They don't just report a problem on a dashboard and wait for you to fix it. They can anticipate it, diagnose it, and even act to solve it.
I'm Sue. So when you look at these practical outcomes, it all becomes so much clearer. We're definitely not just talking theory here. The truth is, agentic solution design can achieve small and large engagement quality and success. Take hyper-personalization in e-commerce. An agent can use a regressor to predict what you might want to buy. Then use a generator to create a personalized marketing email just for you, and then a classifier to analyze your response and learn for the next time. There's just no way a human team could do that at that kind of scale. I'm Bob. Or think about a crazy complex supply chain. A system like IBM's Sterling supply chain software is a perfect real-world example. It's using clusterers to spot unusual shipping patterns that might signal a big disruption. It uses classifiers to identify the type of disruption. Is it weather, a customs issue, a port closure? It then uses regressors to predict the ripple effect on delivery times for everything. And finally, it uses optimizers to suggest or even automatically execute alternative routes in real time. It's a complete, intelligent system that acts to keep goods moving, ensuring that business continuity we were just talking about.
I'm Sue, but, and this is a big but, achieving those incredible benefits is not automatic. It's not about just plugging in a few AI tools and hoping for the best. It requires a really rigorous focus on specific business goals and a very thoughtful, disciplined approach to design, deployment, and especially the maintenance over the long haul. You're listening to OOO TV with research by author Paul Bulow.
I'm Bob. That's absolutely right, Sue. The key insight here, and it's a big one, is that agentic design significantly improves quality and assurance when designed as a complete solution. This is so important. A piecemeal approach, a chatbot here, a recommendation engine over there, that often leads to fragmented, unpredictable, and sometimes totally counterproductive results. The different parts might even start working against each other. But when you design an end-to-end agentic system with one clear goal, all the components are working in concert. I'm Sue. And this really gets to the heart of why agentic agent delivery is critical to achieve business goals. It all comes down to reliability. It ensures the AI isn't just some flashy feature, but a core, dependable part of your entire operational strategy. You have to be able to count on it to deliver consistent value day in and day out, just like any other piece of critical infrastructure.
I'm Bob, right? And that brings us to the next really practical challenge. These systems aren't static. You don't just build them and walk away. The world changes, new data is constantly streaming in, business goals evolve. So a critical question for anyone building or even just buying these systems is this: what are the key elements for agentic design to achieve success with deployment and maintenance updates? How do you keep these things effective and useful over the long term?
I'm Sue. Well, Chris Noah's work gives us a fantastic framework for this. First up, as this slide shows, is continuous learning. The agent absolutely must be able to update its models as new data comes in. Otherwise, its performance is just going to get worse and worse over time. Second, and this one is so crucial, is graceful degradation. What happens if the AI component fails or just spits out a nonsensical answer? The whole system can't just crash. It has to fail elegantly, flagging the issue and letting a human take over in a more manual mode without bringing the entire process to a screeching halt.
I'm Bob.
Right. And third, you need user feedback loops. Users have to have a simple, intuitive way to correct the AI when it gets something wrong, like flagging a bad recommendation or fixing a miscategorized item.
This not only solves the immediate problem, but it also provides invaluable training data to make the whole system smarter over time. Fourth is scenarioizing, giving users the power to play out what-if scenarios to compare different AI-driven predictions. And finally, and this is absolutely non-negotiable, there must be clear, accessible mechanisms for humans to update the system, and most importantly, to override its decisions when they know better. The human is always the final authority.
I'm Sue. And that concept of human authority, Bob, that's exactly where our investigation has to pivot. We've laid out the how, the mechanics, and the business logic. But now we have to confront the why and the what for. Because the very mechanisms you just described, continuous learning from user behavior, feedback loops, decision support designed to nudge our choices, these things are not neutral. As the scholar Shoshana Zuboff warns in this incredibly powerful quote, when these tools are applied not to supply chains but to human beings, they can become something else entirely. She calls it surveillance capitalism, which she defines as nothing less than a direct assault on human autonomy.
I'm Bob. So this really brings us to the central challenge of our era, doesn't it? We are building these unbelievably powerful autonomous agents. The question is no longer can we do it, but how in the world do we control them? How do we make sure that these systems designed to guide and optimize don't simply hurt us in directions that benefit their creators, often completely bypassing our conscious awareness and our consent? This is all about the essential, non-negotiable need for guardrails.
I'm Sue. Which brings me to what is arguably the single most important question of this entire investigation, and it's one that carries an immense amount of weight. With everything we now know about their power, their complexity, and their potential for misuse, can we make agentic AI solutions safe and secure? Is it even possible, Bob?
I'm Bob. I believe we can, Sue, but it requires a profound commitment to embedding safety into the design from the very first line of code. It just can't be an afterthought. The left side of this slide shows a great starting point, what Chris Noel calls universal use cases for safe AI. Think of these as user-centric controls, fundamental rights for anyone interacting with one of these systems. The right to explainability, to be able to ask the AI, why did you make that decision? The right to human intervention, to say, stop, I want to talk to a person. The right to override its advice, and the right to control your own data. These are the practical, individual guardrails.
I'm Sue, but Bob, are those individual controls really enough? I think they're necessary, of course, but I worry they aren't sufficient. Look at the right side of the side. These are the broader, societal-level ethical principles. Transparency, justice and fairness, responsibility, privacy. My real concern is that my personal right to override one bad decision from an AI does absolutely nothing to fix a system that is fundamentally biased or unjust at a societal level. An override button doesn't fix an algorithm that systematically denies loans to people in a certain neighborhood. We're talking about two completely different levels of safety here: individual control versus systemic integrity.
I'm Bob. And that right there brings us to the heart of the problem. What happens when the data we feed these powerful learning agents reflects all the biases, the inequalities, and the injustices of our world? The scary part is these systems don't just automate tasks. They automate and then they scale our past decisions, the good, the bad, and the ugly. This next part of our investigation is about the dark side of that automation: ingrained bias, hidden risks, and the slow, often invisible, erosion of human autonomy.
I'm Sue, and there is no better illustration of this danger than the work of Virginia Eubanks and her concept of the digital poorhouse. She investigated how automated agentic systems for determining things like welfare benefits, child protective services, and housing are used in the United States. And what she found was that far from being neutral, objective, and efficient, these systems are being used to profile, police, and punish the poor. They create a high-tech, automated version of the 19th century poorhouse, a system of surveillance and control that just amplifies existing societal inequalities and makes it even harder for people to escape poverty. You're listening to OOTT TV with research by author Paul Below.
I'm Bob, and these aren't just theoretical risks either. These are documented, real-world disasters. Amazon had to literally scrap a hiring AI because it learned from decades of biased historical data to penalize resumes that included the word women's, like in women's chess club captain. It effectively taught itself to be sexist.
I'm Sue. Exactly. And the Compass software, which is used in U.S. courtrooms to predict recidivism, was found by ProPublica to be twice as likely to falsely flag black defendants as being high risk for future crimes as it did for white defendants. We see it in facial recognition systems that are measurably less accurate for women and people of color, and we see it in large language models that just absorb and reproduce all the stereotypes present in their training data. These systems are holding up a mirror to our society's biases and then using that distorted reflection to make critical, life-altering decisions about people.
I'm Bob. And while those examples are deeply, deeply troubling, Sue, I have to hold on to the promise shown on the left. I mean, the ultimate goal, the whole reason we build this technology, is to overcome flawed human bias, to be more efficient, objective, and ultimately fairer in our decision-making. The technology itself isn't the enemy. It's the flawed data we feed it and the lack of proper human oversight. That's what we need to fix.
I'm Sue. I understand the optimism, Bob, I really do. But we have to confront the peril on the right, which is the reality for so many people today. Data scientist Kathy O'Neill has a name for these systems: weapons of math destruction. And she describes them as opaque, unaccountable, and scalable algorithms that codify and amplify bias, impacting people's access to jobs, loans, insurance, and even their freedom, often without any transparency or any way to appeal. The promise of objectivity can so easily become the peril of automated injustice at a massive, massive scale.
I'm Bob. So where does all this leave us? We've seen the incredible potential of agentic AI. We've seen its building blocks, its business applications, its promise of efficiency and growth. And we have absolutely confronted its profound risks: the amplification of bias, the erosion of autonomy, and the potential for real systemic injustice. The only responsible path forward has to be about bridging that immense gap. It's about moving from these abstract principles to concrete, everyday practice.
I'm Sue. For me, this is the ultimate synthesis of our entire investigation. The final argument really comes from Virginia Eubanks, who reminds us that technology is not some neutral force that's just going to magically solve our deeply rooted social problems. The crucial point is this: we must design our digital, political, and legal systems from an unshakable belief that everyone deserves basic human rights. If we don't start with a foundation of justice, fairness, and dignity, our technology will inevitably and automatically reproduce the oppressive patterns of the past. Ethics can't be a feature you add on at the end. It has to be the very first line of code.
I'm Bob. So we've laid out the components, the methods, and the immense stakes involved in agentic design.
I'm Sue. And so we leave you with this one final thought. We've explored the blueprint for building intelligent agents. The final question for all of us is no longer can we build them, but how will we ensure they build the future we all want to live in? Thanks for joining us on OTTV.